Assalamualaikum and welcome to BFC 15003 calculus. Okay, so in this video, we will learn about second derivative or higher order differentiation. Okay, so in previous video, okay, we have discussed on how to find the first order differentiation, or we can call it as first derivative. Okay, so we know that first order, or we call it as first derivative, is equal to dy over dx, or we can simply write it as y prime, or we can just write f prime x. Okay, so this one we call it as first order. Okay, first order derivative. Okay, so for second order, okay, we can write like this: d square y over dx square, or it is equal to y double prime, or we just write f double prime x. Okay, this one is, we call it as second order derivative. Okay, so for third order, so usually we can write this as d 3y over, okay, dx cube. Okay, also we can just write f triple prime x. Okay, this one we call it as third order. Okay, so for another one is for fourth order. Okay, fourth order, we just write d4y over dx4. Okay, and for fourth order, okay, we can write f 4 in bracket x. Okay, so fifth order, we can write like this: f in bracket 5x. Okay, and so on. Okay, so let's see the first example. Okay, if we are given a function of fx equal to 4x power of 4 minus 2x cubed plus 3. Okay, so the question asks, okay, find the first 5 derivatives. Okay, find the first 5 derivative. Okay, so we can write like this. So f prime x, okay, this one is the first derivative. Okay, when we differentiate our function, we will get 16x cubed, okay, minus 6x squared. Okay, this one is the first. Okay, this one is the first. So how about second? So to find the second derivative, we just need to differentiate 2 times, okay, of our function. Now, when we differentiate, okay, we differentiate our first derivative, we will get 48x squared minus 12x. Okay, therefore this one is the second derivative. Okay, for the third derivative, okay, so we just have to differentiate another time. Okay, just one time. So 2 times 48, we get 96x. Differentiate 12x, we get 12. Okay, this one is the third derivative. So meanwhile, for the fourth derivative, okay, okay, we have to differentiate 96x minus 12, we get 96. Okay, this is our fourth. And finally, for the fifth derivative, we will get 0. Okay, so this one, we already shows the first 5 derivative of this function. Okay, of this function. Okay, let's see the second example. Okay, so if we are given a function of y equal to x power of 5 plus 3x cubed minus 2x plus 1. So the question asks, okay, find the value of, okay, and we have to find y power of 4, y in bracket 4, 2. Okay, so how can we solve this one? Okay, so we need to find the second derivative. Okay, so we just differentiate. Okay, we will get y prime. Okay, so we get 5x power of 4 plus 9x squared minus 2. Okay, so this one is the first derivative. So second derivative, okay, we just differentiate again. We'll get 20x cubed, okay, plus 18x. Okay, so for the third derivative, we just differentiate again. 60x squared plus 18, and the fourth derivative, we get 120x. Okay, so now we already have it. The question asks us to find the second, the third, and the fourth derivative. And if you notice, so we have to substitute. We have to evaluate x at 2. Okay, so now we have to evaluate x at 2. So we see the second one, the second derivative. So we just substitute. Okay, 22 cubed plus 18 2. Okay, so we get the answer is 196. Okay, how about the third? Okay, the third derivative. So we just substitute 62 squared plus 18, and finally we will get 258. Okay, and lastly, we need to evaluate, okay, the fourth derivative. When x equal to 2, we will get 120 times 2. Okay, the answer will be 250. Okay, let's see the third example. So, if we are given a function of y equal to x squared divided by x minus 2, and the question asks find, okay, the second derivative, d square y over dx squared, and answer it in the simplest form. Okay, so from here we notice that we can solve this differentiation by using quotient rule, isn't it? So we have to assume on the top as u and on the bottom as v. Alright, so we already have u equal to x squared. Okay, so du dx, okay, is equal to 2x. So meanwhile v is equal to x minus 2. So dv dx, it is equal to 1. Okay, so it's equal to 1. So if you guys remember, okay, the quotient rule formula, dy dx, it is equal to v du dx minus u dv dx divided by v squared. So now we just substitute everything that we have obtained into the formula. Okay, just insert into the formula. So now our dy dx, we will get, okay, we just substitute v is x minus 2, okay, times with 2x, okay, times with 2x, and minus x squared times with 1 divided by x minus 2 squared. Alright, so when we just simplify everything, and at the end we will get x squared minus 4x divided by x minus 2 squared. Okay, this one is the first derivative, but we need to find the second derivative. So from the first derivative, okay, we know that we get dy over dx, it is equal to x squared minus 4x divided by x minus 2 square. So from here, we need to differentiate another 1 times, okay? So again, we will use a quotient rule, okay, where the first one will be, on the top will be u, on the bottom will be v, okay? So now, we just differentiate again, u is equal to x square minus 4x. So now, u prime, okay, du dx, or we can simply write u prime, we will get 2x minus 4. Okay, for v, it is equal to x minus 2 square. So dv dx, or we can simply write v prime, we will get 2x minus 2, okay, times 1. Okay, we use this one, we use chain rule, okay. And finally, v prime, it is equal to 2x minus 4. Right, so we have everything. We just insert into the quotient rule formula. Okay, so now our second derivative, okay, will be, okay, x minus 2 square, okay, time with 2x minus 4, okay, minus x square minus 4x time with 2x minus 4 divide by, okay, our v is x minus 2 square, don't forget to square. Right, so you just expand and simplify everything, okay. At the end, the answer will be 8 over x minus 2 cube. Okay, try by your own, okay. Try by your own to get the answer. So we will continue the next subtopic in another video. Thank you.